All right, so what we're looking at here is a vector question, all right? So given that PQ is equal to 5, -4, if P is the point, so this is the point P, the coordinate of it is -2, 3, they want us to determine the coordinate of Q. What I want us to understand is if we're dealing with vector and we get the coordinate of a point, we have indirectly gotten the position vector leading up to that point. For example, if I got P, which is -2, 3, then the position vector OP is actually -2, 3. So we want to differentiate understanding the coordinate form compared to a vector form using those same numbers. Now, question, if I'm going to try to find the coordinate of the point Q, then I'm going to try to find the position vector OQ. So if I do find that position vector OQ, then the vector that I find will actually be the coordinate of the point Q. So let's go about searching for OQ. Now, if I want to find the position vector from O to Q, there are more than one ways I could do this, but I'm just going to pick on this. I could move from O to P, and then I walk myself from that to P to Q. So take a look. I'm moving from O to Q. I could walk from O to P and then from P to Q. Let's take a look at what we got. Here it is that we have OP, and we're heading in that same direction. So OP, which is -2, 3, and then I'm moving from P to Q. PQ, right, was given already, and it's given as 5, -4. So all we're doing here is to add matrices. So it's -2 plus 5, and then 3 plus -4, and we are actually left with +3, -1. But this is the position vector OQ. The coordinate of the point Q, so I'll just say point Q, the coordinate is going to be writing the vector in a coordinate form, which is 3, -1. And that's how we capture that point right there. So we want to understand those little ideas. Now, let us jump into another question. So we're looking at a pentagon here, OABCD. OA, we were told, is actually parallel to DC. In other words, this is parallel to this, and we've gotten that OA is also parallel to DC, right? So we have some parallel vectors coming out right here. Now, let's see what we have to do. OD is 2AB. So OD is 2AB. In other words, then, AB is B. That means this is going to be 2B, because we were just told that OD is twice AB. So I would be able to relate this to that, right? So we did that relationship very quickly right there. All right. What else? We also got information that OA right here is 2 times DC. OA is A. So DC is going to be a half A, very simply. So labeling your diagram is an easy way of walking through the rest of questions. Now let us look at what they want. They want us to find, in terms of A and B, from A to D. So I need to find this. And we want to pay attention to the arrow, right? I'm heading that way. Now, what I'm going to do is to do a quick triangular walk, where I'm going to walk from A to O, and then I'm going to move from O to D. So right there, I would have connected from A to D. So I'm going to utilize the triangular walk. So set it up. If I'm moving from A to D, I could simply move from A to O, and then I move from O to D. What I want to do now is just to look at the direction in terms of the arrows that we're given. So if you pay attention to this arrow, it's going against the direction, because I need to come this way. The arrow was going the opposite way, which means that I'm going to use the inverse of it, which is to say -A. because I'm going against the direction of the original vector that I was giving. I will be using OD in the same manner, which is positive 2b. And this is already simplified. So AD is negative A plus 2b. We're done with that. BC. Now we were asked to find BC. Let's take a look. I could work BC out anywhere. I could do BC here. Now, if I'm going to move from B to C, which is here, I have a number of trips that I could take. I could go around the world. For example, I could walk from B to A, then go to O, and then come here, and then go there. It works. And if I don't want to do that, I could easily move from B. I could move from B to A, to D, and then to C. So doesn't matter which one of the routes you take, you'd end up at the same place, right? So let me just write one. I'm going to move from B to A. Then I'm going to move from A to O. Then I'm going to move from O to D. Then I'm going to move from D to C. The point is that I left B and I ended at C. The moment there is no error in the calculation, your answer will be correct. Let us now look at the arrows, the direction in which we are going, and the direction that was already placed on the diagram that we got. BA, as you could see, I'm going opposite to the direction here. So it's going to be a negative B for me here. Then I'm going to come against this again. So I'm going to go in negative A. But my OD is in the same direction. So it is positive 2B. And my DC is in the same direction. It's positive half A. What I want to do here is to collect my like terms. For example, negative A plus half A are alike. Negative B plus 2B are alike. So when I look at the A term, negative A, which is negative 1A plus half A, I'm going to be left with negative half A. All right, so negative A plus half A, that's a negative half A. Negative B plus 2B, that is actually 1B, which is just B. So the vector BC is actually negative half A plus B. All right, so we have that done, right? Now, so here it is. This is actually negative half A plus B. Now, let us see the last question. So the last question is asking us to state the conclusion about the magnitude of AD and the magnitude of BC that can be joined from those two responses. Let us write the responses that we got. We had it that AD is actually negative A plus 2B, and BC is actually negative half A plus B. So here it is. These vectors, if you take a good look, if I should multiply BC by 2, for example, if I should multiply this vector here by 2, then look what we have. 2 times half A plus 2 times B. If I simplify this, I'm going to have negative A plus 2B. Take a look. This is actually the vector AD. So what this means is that the vector BC is parallel to the vector AD. Now, whenever two vectors are parallel, that scalar quantity that is used to identify that factor that is used to change one vector to the next will also affect their distances. So what happened is, you could see that 2 times the magnitude of BC is actually the magnitude of AD. That is the relationship with their magnitude. If I multiply the size of BC by 2, I'll get the size of AD. That's one way of putting it. A second way I could have looked at the relationship, I could have said half the magnitude of AD will give me the magnitude of BC. So whichever one of these responses that you would have picked would have given you the answer. Thank you for watching Daily Maths Concepts. Like this video, subscribe, and drop a comment. See you next time.